How's it going, YouTube? Welcome back to the channel. So today what we are going to do is that we are going to create an offline AI research assistant with Gemma. So Gemma is the open source models which are available, not necessarily, but like still Gemma has released some open source models which can be used in your device offline. So the idea is that I like most of the time what will happen is like we will upload certain documents or confidential documents or your salary certificate or your resume into the ChatGPT or any other LLM devices. Then what will happen is like they are actually using your data to train their models as well. It's a continuous process. So sometimes these are the kind of things which we don't want to happen, right? These are our personal information, which is like in cybersecurity world, it is actually called PII, personally identifiable informations. So which we don't want to happen. So as I'm working in a cybersecurity industry, I have seen this happens to so many people. Even in our organization itself, we have seen so many people who are uploading confidential documents into their system, into the LLM, which is not feasible or like even from a compliance standpoint, it's not correct. So today what we will do is when we will create an LLM that can be ran on your local machine itself, like without internet, it's not even connecting to the cloud at all. So the ideas are actually huge. We can actually create a model that runs on your laptop or your iPhone or your Android phone, like whatever it may be, so that you can have an LLM which is running in your machine itself. So if you notice, this is the end product which we are going to get with. So you can actually upload a PDF file, or you can even like paste a text over here, and then we can ask the LLM to generate a summary. So for the sake of this video, we will be just doing the summarization of the text whatever we are going to give. Like let's get into the example itself. So if you give any resume, this is my resume like from look back. So we can set the maximum output tokens to 2048, which we can control by the way. And then when you give summarize, like I'm running in a MacBook Pro M3, so it can actually finish in like around 8 seconds. So even though it's kind of like a huge time, but still this is okay, right? Your information is actually being processed in your machine itself. So you see that like you will get a proper answer, and then we can also actually use multiple documents in it, and then we can also support more than one type of files. So there is a correct audience for this. And then Google has recently released embedding, not recently, like it's been like almost a month or 2 months now, which they released embedding Gemma, which is the model which actually converts whatever text or image that you give into the numbers, and then you can build it from there. So without further ado, let's get right into it. So what I will do is I already have a folder called embedding Gemma over here. And then what like you have to have at least Python 3.13 for this tutorial if you want to follow through. So I'm going to check if my system has Python 3.13, and then yeah, I have it. So if you don't have it, you can install it based on your operating system. Just search for how to install Python 3.13 in your machine, and then you're good to go. Once you have that, you might have to create a virtual environment. So I'm going to create using this particular command called Python 3 VNV, and then like I'm going to call it Gemma VNV. So once you put the command, you will get a folder over there itself saying Gemma VNV is there. So you have to activate it. So whenever we are actually wanting to use any like libraries which are related to this particular project only, then if you use a virtual environment, it will be useful for you. So if you do source Gemma VNV bin activate, now you see this Gemma VNV over here, right? So this means that whatever commands you are running on from now on will be installed in this particular virtual environment. So you can actually activate it and deactivate it. If you do deactivate, then you are in the global Python environment. So if you want to have it in your local, and then this is the way, right? And then now you can actually do, in the GitHub repo, which I will link later on, you will have a requirements.txt, like so. I will show it to you in a second. So if you notice, there is a requirements.txt over here. So if you have this file, then you can just do pip install -r requirements.txt. So I'm going to do that in a second. Let me just copy it real quick to the directory I had. Okay, it should be there now. I have done that. We will go to a terminal. And then if you notice, it's actually there. Yeah. So we will do pip install minus r requirements.txt. So when you press enter, it will take some time to actually go through it. That you will eventually find out like it will install everything, because like I have been installing it in my system, testing it out. It's actually getting it from cache itself. So in your case, it might be going to the internet and then it will install from there itself. So once that is done, you can actually go ahead and we will wait for it to complete. Once that is done, we will go ahead and create an assistant.py. So in this particular case, I'm not going to be building out the whole code itself. I'll be putting that Python file in GitHub. So you can just copy that and then use it or build it from there. I'll just explain to you like how the code looks like. So if you notice, the pip installation has been completed. And now if you go to our VS Code, I had assistant.py, so you can create any name you want to actually create. So this is in my previous case, I have created an environment like this. So you have all these bin and install files and everything, which we don't have to care about. And then this requirements.txt I just showed you, and then you have assistants.py, right? So in this particular file, what we are doing is like we are going to import Torch, like it's actually Python's machine learning like suite of tools which we can make use of. And then after that, we will also import from transformers, auto tokenizer, and auto model for Cosarella. This I will go in detail once we get here. And then like I'm going to use Grade.io as the UI library for this particular tutorial, because like I feel like I don't want to actually create a whole UI just to, show like what are the feasibility of this particular tool. And then we will also use PyPDF2, just like to, parse the PDF2 into a text format. So I'm just going to create a read PDF, and then like whatever file path you give, it will actually open that in your memory, and then like to read from there, and then like all the text has been extracted and it will return a text. That's it. It's a simple function. Okay, and then this is the start of our like actual things. So when you run a Python file itself in the beginning, it will actually go to this particular section, if name equal to main, and then it will actually call demo.launch. Yeah. So if you notice, demo is actually used from here in the GR blocks. So Grade.io has something called block. It's a block builder which is built in Python itself. So what we are doing is like with the gr.blocks, and then I'm using a theme from like called Hacking Face, which is already there. And then what is the title for it? And then I'm calling it as referencing the whole section as demo. So the moment the Python file is ran, the demo.launch will trigger, which will trigger this one. And then what I'm saying is that like I want the Grade.io to actually print this particular text in Markdown format. So Markdown is like a standard which we can use to show text and headings and everything. So one hash means it's a like h1 tag. So I'm just using it for sake of this particular video. You don't have to like actually go through it one by one. But if you want to actually use a UI which is built on React or Tailwind and Next.js, it's up to you. You can create it, and then you can stream from this particular out from this particular Python file to your UI itself using WebSockets. So yeah, and then you can actually like I'm saying that okay, I want to actually see this text after this as a like small text. So if you notice in our UI itself, you'll get to see this, right? So this is a like heading, and then you have a summary like in a smaller text. And then if you notice in a row, you have two sections. One is like, to upload the PDF file, and the second one is to actually paste the text over here. So that also you can find it. Like I'm saying that in the Grade.io, you have to create a row, and then like first one is like, file input, and the second one is text input. So one is like, file upload box, and then the other one is text box. It's very straightforward. And then like this max length slider, let's say you want to have, the output in a limited number of tokens. You don't want it to go like, infinitely huge. So if you notice in ChatGPT and Cloud and everywhere, what will happen is like the output can go huge amount. So in this particular scenario, like since we are summarizing the whole thing, we can actually limit it. We can set the value to either 512 or 2048. So if you limit it, your CPU will also be like able to process this particular thing much more smoother and faster. But if you increase it a little bit more, and then that's going to be also another issue. Like it will like if your CPU has enough memory to actually process it, then you can set it to 8192 or like up to you, maybe 16,000. That's up to you. But like for this one, we will stick with the 2048 as the maximum, and then by default it will have 512. And then this is just saying that, okay, I want a slider with the minimum and maximum values. And then after that, you're gonna just give an output text in a text box and then the summarize button. So like, yeah, this one, that's it. And when you click on the summarize button, I am calling a function called summarize with the inputs which I got from these, like this place, right? The file input, text input, and then the max line slider, and then where I'm gonna like actually put the output. So this particular output text is the element. I'm gonna directly map it over here. So when you click on this, I have to go summarize. So if you go to summarize, if you look at it, like you have 3 arguments: file input, text input, and max length parameter, right? And inside that, this is all just parsing the text. If there is a file, you are reading it, and then if not, please upload a PDF file. And then, like if you have a text input, then like you are saying that, okay, if it's not, if it's there, you are stripping it, and like, you know, you are assigning to a text variable, which is the variable, local variable over defined over here, defined over there. And then you have max length. We are getting if max length is defined. If max length is not defined, some error checking. And then if not text, yeah, like we weren't able to actually extract it, or the text field is empty. And then we can have multiple prompts, by the way. So this one is actually one of the cool things. So in this particular example, I'm going to be, you know, giving out only summary of the uploaded file or the text which we have written over there. So we are saying the LLM model that, yeah, please read the following text and provide a concise summary of it. The summary should capture the main points and key findings, ensure the output is only the summary and nothing else. So text to summarize whatever we have actually given from the PDF or the text input box, and then like what is a concise summary, and you are asking the LLM to actually process with it. So we are using Gemma 2 billion instruction tuned model. So what this model is specifically trained for is that it can have until 2 billion nodes. It will have 2 billion nodes so that it can actually process it. It's kind of fairly lower on the lower side, but still for our use case, it should be fine. And instruction tuned is that it's going to work in a question answer scenario. Like you ask some question and it will return an answer. So this is the kind of model which you're using, and it's very fairly, you know, lower footprint. It doesn't have to have, you know, a huge amount of like CPU or RAM or VRAM and everything. So once you have the prompt, you're actually using tokenizer. So what this tokenizer does is that if you go here, we have mentioned tokenizer over here, and then we are actually using auto tokenizer module from the transformer module. Auto tokenizer auto tokenizer like import from the module transformers. So over there, if you notice, like we are saying that, okay, this is the model ID I want to actually download. And then if it's there in the cache, then you can use it from there, or it will download for the first time. So most likely when you actually run this, it will take it will take some time to actually download it, and it will keep it in the cache. So the next time onwards, it will be working fine. So what it does is like it will convert the given text into machine identifiable numbers, right? So the machine cannot actually know what are the text you have given over there. It has to convert those text into numbers so that the machine can actually understand, okay, you're talking about this particular scenario. So that's actually a huge topic, how the tokenization works. So for this particular for this particular video, we will think that, okay, the tokenizer, what it does is like it will convert the given text into numbers, which the model and the CPU can actually work with. And then once that is done, we will also import auto model for causal LLM. So it's a kind of like language model which predicts the next keyword. Okay, so you are starting with one keyword, and what is the next keyword that's going to be likely, which is coming from the previous one. Looking into the previous one, it will predict the next one. So that's the usual, like that's how most of the LLM works over there out in the wild, right? So we are going to use the same thing, which is already, you know, defined for us. We don't have to do anything else. So what we are going to do is that I'm going to make sure that I want this particular Gemma 2 billion instruction tool model should be there. And then I'm going to say that. So this device map is actually like I have set it to auto. So if you have a GPU in your machine, then it will automatically take the GPU. If you don't have a GPU, then it will automatically run on CPU. So that's what this device map auto does. And then data type means that, like, let's say we are actually like, what is the data type you want to actually return to? So in this particular case, we are using PyTorch. So in that PyTorch, I'm setting the the bit parameter, like how much do you want to actually process this. So this is a floating point, a 16-bit parameter we are going to actually be processing on. So you can actually give it to float 32. That's also fine, but like that will give you more accurate answers, but that will also consume a lot of RAM and VRAM. So it's better to go with just B float 16 if you don't have a huge beefier GPU in your system. Okay, and then once you have the tokenizer, it will actually call that and convert it into the numbers as we talked about. So this return tensors is actually convert PT means like PyTorch tensors. So this will particularly return whatever text you have given in a number format which is acceptable by the PyTorch and the tokens which we can actually identify. And then it will make sure that it runs on this particular model device we have mentioned over here, right? So in this particular case, it's actually auto, but it can run on either GPU or CPU. It'll automatically do that for you. And then you have outputs. I'm going to call the model, which is already defined over here, right, in this particular section. So I'm going to call that model, and then I'm going to say that, okay, I want you to generate this particular input IDs related things, which is this question itself. And then like, what is the maximum output tokens I want, which we have defined in the UI itself, right? We told that we want just 2048. And what is the pad token ID? So which means that like, I don't want the LLM to create, like a huge amount of keywords just to fill it up. So usually you say that end of that particular line, end of that particular response itself, and then that will given as the pad token. And then do sample means do sample true. If you set it to true means that rather than actually, like predicting the next word, likely word, it will actually create a pool of data from your document itself. And then it will, like what is the most possible keyword from that particular pool. And then it will use that. So we can actually define the parameters for that as well. So in this particular case, top K means that pool, like what is the size of that pool maximum should be. So when you give it a sample, it will create 50 likely possible words with their probability. So we can choose from that particular pool saying that, okay, if one of the word is actually more than 0.95 probable, then we will use that as the next word. Yeah, that's the oversimplification of this particular section, how the LLMs work. And then once that is done, we will actually summarize it. Like the summary should be the decoded value. So once this output is there, that output is actually still in a machine understandable format. It's still not in a human readable format yet. It's in numbers. So this tokenizer decode option will actually give us back the decoded format, which we can read it, right? And then these special tokens, like, and usually in cases like, if we can see that, we will see like a certain, when did the string start and when did the string end, along with the pad XML tags over there. So those kind of things, we will remove it, and then we will convert that into human readable format. And then we will replace with the summary section, which we have mentioned, like when we return it, it will be replaced with this output.txt. So yeah, that is a simplified version. And then the output will be like this. You can actually give the upload file, text over here, and then you'll get a generated summary. So yeah, that's it for the video. So if you guys have any doubt, or you I went through something really quicker and like you want to understand more about it, let me know in the comments. Then I'll shoot a series, and then we can learn more about it. Thank you guys. Thank you for joining in. Please subscribe if you like this video. And then thank you. We'll see you soon.